In this video, we're going to have a look at trig graphs and what happens when we've got a vertical translation. Okay, what I'd like you to do is to copy down this graph into your jotter. Okay, hopefully you can see that this is a graph of y equals 5 sine 2x degrees. This is our x and our y axis. Okay, it's 5 sine 2x degrees because it goes up to 5, down to minus 5, and in 360 degrees there is 2 revolutions of the sine graph. What we're going to have a look at today is what happens if we've got the graph of y equals 5 sine 2x plus 3, or subtract 6, or minus 1. What would that graph look like? And in order to think about that, I want you to think about the graph of the quadratic y equals x squared. I'm just going to sketch this down here. You don't need to do this. But see the graph of y equals x squared, this guy here. Notice that it turns at 0, 0. See if I wanted to sketch the graph of y equals x squared plus 2. All that would happen is I would shift all my points up 2 places. So this would be y equals x squared plus 2. So this point here has been shifted up 2. This point here has been shifted up 2 over on this diagram on the right. The same thing holds true for trig graphs. What we can do, let's drop that out, is we can sketch graphs of the form y equals sine x plus a, for example, and see if the value of a is positive. That means the graph moves up by that amount. If the value of a is negative, it moves down by that amount. I'm going to show you here on the right the graph of y equals 5 sine 2x plus 1. Okay, that's in blue. So this is the graph of y equals 5 sine 2x plus 1. That's our y-axis and our x-axis. Allow me to explain why. So our normal 5 sine 2x would start at 0, but because we've added 1, it starts at 1. The maximum of this graph is 5, but we've added 1, so the maximum is now 6. The minimum is minus 5. The minimum, it becomes minus 4. Our graph finishes at 360. Similarly, if we were to take this across, our graph finishes at 360. Okay, so this here is the graph of y equals 5 sine 2x plus 1. You might sometimes be given this graph and be asked to write down this equation. First thing you do is you look at, is it sine or cos? Well, this is sine. Then have a look at the maximum point and the minimum point, 6 and minus 4. Do you see that these 2 points are 10 apart? Because it's 60 here and 40 here. So altogether these are 10 apart. To get your amplitude, you would half that 10 to get 5. Okay? So that then gives us an understanding of, okay, it should look something like this. It should go up to 5 and down to minus 5. But ours doesn't. Ours goes up to 6 and down to minus 4. Therefore, we must have moved up that 1 place. So you need to be able to draw the graph and also be able to look at the graph and identify what the equation is. Okay, here's another example. We've got a graph on the left here. I'm going to ask you to note down. This is the graph. Well, let's have a look. This is a cos graph. It's going to be y equals, it goes up to 7 and down to minus 7. So it's going to be 7 cos. And how many revolutions do we have in 360? I've got 1 revolution, so it's going to be 7 cos 1x, or 7 cos x. Okay, what we're going to do is we're going to sketch the graph of y equals 7 cos x minus 6. Okay, which we've got here. Y equals 7 cos x minus 6. Let me to explain it. So 7 cos x starts at 7. But if we're subtracting 6, it's going to start at 1. 7 cos x has a minimum point at minus 7. So 7 cos x minus 6 is going to have a minimum point at minus 13. All the other points here stay the same, but everything is moved down 6 places. So this is the graph of 7 cos x minus 6. The last thing we're going to have a look at is to be able to see a graph and identify what the equation is. So here, this is quite an exam style question. Write down the equations of the following graphs. Well, let's have a look at the one on the left. The first thing you need to ask yourself is, what is the shape of this? Is this sine or is this cos? Well, this is a cos graph because it looks like a valley. So it's going to be cos. But we need to work out, is it 4 cos, 5 cos, 6 cos? Because see if both of these values were the same. For example, see if this point here was 5, then straight away we could go ahead and say, oh, it's 5 cos something. But the points are not the same, so we can't go ahead and do that. What we need to do is we need to work out how far apart are these points. How far apart are these points? Well, if you notice that from here to here is 3, and from here to here is 5 altogether. Yeah, 3 and 5. So altogether they are 8 apart. So to work out the amplitude, we half that 8. So it's going to be 4 cos. We then need to work out the period, how many revolutions in 360. Well, I've got 1 revolution 180. There's 1 revolution. So if I've got 1 in 180, I'm going to have 2 in 360. So, okay, so we're looking at 4 cos 2x. If we were to picture this in our brains though, 4 cos 2x would go up to 4, or would start at 4 and go down to minus 4. We start at 3 though, we don't start at 4 as we expect, we start at 3. We don't go down to minus 4, we go down to minus 5. So do you notice that we have went down 1? So this is the graph of, this is the equation of the graph here. 4 cos 2x minus 1. It's got an amplitude of 4. So we would expect it to start at 4 and go down to minus 4. But it starts at 3 and goes down to minus 5. It's moved down 1 place. And there are 2 revolutions in 180. Sorry, there are 2 revolutions in 360. 1, 2. Okay, let's have a look at this last example here where we want to identify this equation. So what is it? Is it sine or cos? Well, this is sine this time. So we need to have a look at the difference between the maximum and the minimum point. So the maximum point here is 7. The minimum point is minus 3. So we need to work out how far apart are those values. So hopefully you can see that those values are 7 plus 3. They are 10 apart. So this is the graph of y equals 5 sine, because we half that 10, the amplitude is 5. How many revolutions do we have in 360 of sine? There's 1, 2, so we've got 2 revolutions. So it's 5 sine 2x. Now we need to figure out, is there any translation? Because if it was 5 sine 2x, it would go up to 5 and down to minus 5. But we've went up to 7 and down to minus 3. So do you notice that we've actually had to shift up 2 places? Yeah, to get from 5 to 7, we've had to move up 2. So therefore, this is the graph of y equals 5 sine 2x plus 2. Okay, so to identify, once again, to identify the amplitude, you figure out the difference between the maximum point and the minimum point, and then you half it. To work out the period, you're looking for how many revolutions are there in 360. If you're given 180, you'd need to double it, for example. And then for this value here, you need to kind of compare what you think this graph would look like in your brain and what you have. If you've got 5 sine, that should go up to 5 and down to minus 5. This goes up to 7 and down to minus 7. Or sorry, up to 7 and down to minus 3. Well, then it has to have shifted up 2. You could also note that sine x should have started at 0. and sine x here has started at 2. It has moved up 2 places. Okay, hopefully that's been helpful, and you can now start to have a look at some work where you have to work with vertical translations of trig graphs. Thank you very much.